Welcome everyone to today's live session on NPTEL problem solving for the Natural Language Processing course. I hope you have gone through the videos for for week 9 that covered widely the topic models and the different latent Dirichlet allocation. That is one of the topic modeling techniques, and several other variants have also been discussed. So let us see few questions related to that. Please confirm if my screen is visible. Slides are visible to you? Please
Yes, ma'am.
confirm. Anybody?
Yes, ma'am. It's visible.
Okay, thank you. So let us start. Uh, so please attempt this question and put your answers in the chat box. So this is single option correct. So they ask for like what is LDA topic model, whether it is supervised, semi-supervised, unsupervised or reinforcement learning model. LDA here stands for, okay. Please attempt everyone. I would encourage all to attempt and put your answers in the chat box. We will see shortly what is the correct answer and the explanation behind it. So this is what LDA stands for. I hope you are aware of it. Please give it a try and put your answers in the chat box. So Sandeep says option C. Okay. How many others say option C? Three of them are saying option C. Okay. We'll give you 1 minute more. Vidya, please attempt. Please put your answer in the chat box. Great. I think all the people present here have put the answer. So let us see. So LD topic modeling is a unsupervised learning algorithm. All were correct. Why is it so? Why is it so? So why is LD topic modeling an unsupervised learning algorithm? Let me explain. So So in this, I do not know what are the topics beforehand that can be assigned to the words that are present in my document. Okay, I am not. So it's like I'm not aware of what are the topics that are present in my in this case of latent Dirichlet allocation. Though I can specify the number of topics beforehand, but I do not know what those labels are. Labels here refer to what those topics are. So, given the words like play, fun, football, or books, school, exam, the model can identify that this set of words should fall into one cluster, or this set of the words should fall into another cluster, but it does not know the topic beforehand, whether it belongs to education and stuff, or whether it belongs to outdoor activities or playing stuff. So these kind of labels are not given to my topic modeling algorithm. In the case of latent Dirichlet allocation, that is one of the topic modeling algorithms. These labels are not given beforehand, but I will just specify the number of the topics. I will not specify what those exact labels are, but still my model can identify, given this training data, it will learn and it will identify that this category of word should fall into the first category and this should fall into the second category. So, though I have not given the what are the exact labels, still the model can identify whether they should be closely related or not. So that's why we say that this is an unsupervised learning algorithm. That is, they do not require any prior labeled data. So in case it requires the label data, then it comes in under the class of supervised learning algorithms. Here I know what are the categories or what are the classes my data should fall into. That is also known as the ground truth. And in the case of semi-supervised, it is a combination of supervised plus unsupervised. And in the case of unsupervised, you do not need the labels beforehand, as we saw in the case of LDA topic model. You do not, it can work on the unlabeled data. It does not need to know what are the classes that the model needs to be assigned into. So one of the very popular applications under this category is clustering for unsupervised. And reinforcement learning is like you give the model some data, and based on the feedback, it is like based on the reward feedback system, action and reward kind of learning is there in under the case of reinforcement. So I hope it is clear to all now why LDA is an unsupervised learning algorithm. If you have any doubt, please ask. Please let me know in case you have any doubt. No response? Is everybody there? Am I audible?
Yes, ma'am, it's
Okay, okay.
audible.
Okay, then let's move to the next question. So, the question says which linguistic phenomena can cause the same word to be active in different topics? Like in the topic models, given a word, whether the same word, so the question asks you whether the same word can fall or can it belong to multiple topics. So, given that this condition is there, which property of the linguistic sides of the which property of the linguistics can enable this mechanism that the same word can belong to multiple topics simultaneously? So you have been given the option agglutination, maronymy, polysemy, all of these. Maronymy, I hope you know, it's like part of the whole, part of the whole. That is maronymy. Like legs is a part of the table. So we say that leg is a maronym of table. And if you are to model the reverse relationship, table is a holonym of leg. Okay. Attempt this question and let put your answers in the chat box. Let me know what you are getting. Everyone, please give it a try. Someone says polysemy. Okay. Okay. Great. Okay, let us discuss. People are already giving the answers. So the correct answer is, of course, option C, polysemy. Why? Let us see. So what is polysemy?
So basically, the word has multiple meanings.
Yes, yes. Like same word, it can have multiple forms or meanings in different context. So you need to identify the context for this. Here poly means many, and semi, it is derived from semantics, where the word semantics means what is the meaning of it, meaning of this particular, what does it refer to. So let's say I have two topics, okay? Let's say this is topic 1, this is topic 2, and I am having say, multiple word. Let's say here I have bank, loan, money, interest, okay? And let's say another, I am having river, stream, bank, water. My writing is legible to all, right?
Yes, ma'am.
Okay. So let's see here. Word this, see the same word is there. What did I write? Same word. Word should be same. No change in spelling, no change in sound. Okay? But it can have multiple forms. Let's say this word bank. And here also the word is bank. But why the same word is belonging to different topics? Here this word bank is referring to as a financial institution. So here it refers to a bank as a financial institution. And if you see what are the surrounding words for this bank under this particular topic T2. So what are the surrounding words? River, stream, water. So what can we derive from this? That this bank refers to the side of the river where there is a lot of sand, and we go for along the river bank to take a walk like that. And I hope you understood this. Let me give you another example for the same. So let's say we have another topic 3, T3 and T4. So let's say here it's fair, toys, swing, like that. And in T3 you have behavior, evaluation, polite, fair. So if you see here this word fair, fair. So what does this fair refer to? From this, seeing the context, I can derive that this is related to some entertainment related activity. There are a lot of swings, toys, people, chaos around. And what does this fair refer to? This refers like being impartial, equal treatment. So is it clear to all now what does polysemy means and how this property enables the same word to be assigned to two different topics? Is it clear to all?
Yes, ma'am.
Okay, great. So let us see the next question. Just a second. If you have gone through the lectures, then these questions will be very easy to attempt. Kindly go through the lectures before coming to the problem session, session problem solving sessions. This will help you to solve the assignments that are being given. The questions in your current assignments are very closely related to this, and this will also help you in your exam preparation. So let us see this question. What does this say? Which family of distribution can be used to parameterize the probability distribution over the probability distributions? So this is like we are to find the probability of something. So it is asking whether multinomial will allow Dirichlet, Poissons, or gamma. So just give it a try. This is very nicely covered in, I think, lecture 43. So please give it a try, everyone, and put your answers in the chat box. We will discuss. Others also, please give it a try and put your answers in the chat box. Please try, everyone. This is the question. Shall we discuss? So
Yes.
here the correct answer should be option B, Dirichlet distribution. So let us say I have three words: books, science, toys. And let's say my topic is education. This is W1, W2, W3. And this is my topic. So here, what is the probability of the word W1 to be assigned to topic? Let's say another topic that I have is, let's say T1 is related to fun and T2 is related to education. So what is the probability of the word 1 to be assigned to the topic 1, or the probability of word 2 to be assigned to the topic 2, or the word 1 to be assigned to the topic 1? So let's say for I have this matrix kind of, and here I have the distributions like W1, W2, W3. And this is, let's say, for books it's zero point 0.5, for science it's zero point 0.4, and it's for this it is zero point 0.1. And for this it is 0.01, 0.02, and this is zero point 0.7. So what is the probability that I will prefer this distribution of words over this distribution? So probability of probability. Why do we say probability of probability? Why? Because what is the probability of the word topic W1 belonging to topic T1? And in that case, what will be the probability of this entire distribution? So that I can model with the help of only Dirichlet distribution. And in the case of the simple LDA models, we use Dirichlet distribution. From the name itself, you can see LDA, where this L stands for the latent Dirichlet allocation. So Dirichlet distribution is used to allocate the parameters of the model, that is alpha, beta, and z, that we will see shortly. And why latent? Latent because, as we discussed in the first question, we do not know what are the topics beforehand. We do not have the labels, but if we try to see what is the hidden structure using the different words that are present, we still can derive that these should belong to one cluster or another cluster, though we do not have an explicit label for that. But we can still try to understand whether these should all belong to one topic or not, these should fall under the same topic or not. Okay, any doubts, anyone? Please ask if you have any doubt. Okay, I think that there is no doubt. Anybody, any doubt? Any doubt? Is it clear to all the explanation? If you think that there is any other reason or you have any doubt, please let me know. Okay, please attempt this question then. I think there is no doubt. Attempt this question. So we have been given the LDA model and we have discussed the graphical model of LDA in lecture 43. So they are just asking now what are the latent random variables. In lecture 43, it has been discovered in covered in great detail. How do we get, what do we get, what does this beta, z, theta, alpha, eta, k stands for. So based on that, we are to just identify what are the latent variables. And this question is multiple options can be correct in this. Like 1, 2, 3, 4, all can be correct. 2, 3, 4, any combination can be correct. So please carefully mark all the correct options and put your answer in the chat box. We'll discuss in 3 minutes. I'll ask what is alpha, eta, theta, beta, k, d, w, n. Please be ready. This is very important. You need to understand what is the graphical model, how does it work, why we are modeling it in a particular way. Here the word latent means hidden, that we will compute from the model. Everyone, please solve. Please put the answers in the chat box. solve. Not understood properly. Please explain. What question you didn't understand, Siddharth Singh Kushwaha? Which question? The present question or the previous question? Please unmute and tell. This question. Okay, okay. We'll discuss. Wait. We'll discuss. Okay. So I will explain this. Slide. The current slide. Okay. So we'll explain it here only. So here, if you remember, capital K, capital N, capital D. This is one set. Alpha, eta. Then what are other things? Z, W and beta K. Z, D, N, W and beta K. W, W, D, N. Okay. So, I will explain. K here stands for the number of the topics, and N stands for the total number of the words, and D stands for the number of the documents. So the basic the base so the basic assumption or how the construction goes is like we assume any corpus or any data set that is built of documents. Multiple documents can be there. A document can be made up of multiple topics, and under topics there can be multiple words. So we are assuming, let's say we have one data set. In this particular scenario, the data set is defined already beforehand. That is a static data set, not changing over time. Okay. And in that, capital K is the number of the topics that we have. Capital N is the number of the words. These are the standard notations. And capital D is the number of the documents. Alpha and eta, these are the hyperparameters. Here, alpha is used to tune what should be the probability of the topic. How much high, whether it should be given a high probability or low probability. Let's say my document can be made, since it is made up of capital K topics. So we are having T1, T2 up till some intermediate document is represented by small k, and total number of topics is capital K. So whether in my corpus, for the document D, what topics should be assigned, like all the topics, whether they should be given the equal probability, or T2 should be given, probability of T2 should be higher than the probability of the topic T1, like this, or the probability of topic T2, T3, like this, that should be higher than T1 and T4. Like this kind of the tuning is done by alpha. And similarly, eta will tune for the words. So this is used to control the probability of the topics, and eta is used to control the probability of the words. So what is zeta dn here? What is zeta dn? So small d is here your document D, and small n is the nth word. So if you know what is this WDN, this is like what are the words that I am observing in my corpus. This is the observable words that will occur for any new document. Okay, and here zeta d zdn and beta k. Here this is small k. So what is the probability like this particular word should be there? So in the case of LDA, I am to determine two things. I am to determine the per topic distribution and per word distribution. So in the per word distribution, it means what is the probability of the different words belonging to a given topic. That is computed by probability of the word that it belongs to the certain topic. And here per topic distribution, given the document D, what are all the topics that can be assigned to this document? So what are all the topics T1, T2, T3 up till TK? What are all the topics given the document D? What are all the topics that I can assign to this document? So here ZDN is used to represent, given that the document D and every topic will be composed of multiple words. So how we will compute this ZDN? That will be what is the probability of the word belonging to a given topic multiplied by what are the topics that can be belonging to a given document. This will help me to find it out. And beta k. What is beta k? What is the probability of the word belonging to a given topic? So these two I have to compute, and that's why these are referred to as the latent variables. So here the correct option would be 2 and 3. Sorry, not option 2. 3 and 4 will be the correct. This is your observable random variables. That is, given any new document D, what are the words that appear in it? Like the N words are there. What are the different words appearing in this document D? Words in document D. And alpha, I told you, it's the hyperparameter used to control the probability distribution of the topics. Okay. So is it clear now, Siddharth? So answer will be 3 and 4. Siddharth, please tell if it is clear or shall I explain again? Okay, okay, great. Anybody, any doubt in this problem formulation? Please unmute and tell. Please be as much interactive as possible. Please unmute and tell if anybody is having any doubt anywhere. So if you see how this structure has been defined in this diagram, like it has been clearly given. So this is like your, assume that this is your entire corpus and this is your document D, like the total documents. And the document is made up of multiple topics and the topics are made up of multiple words. So this theta D is like your per topic assignment. And your beta k is per word assignment. Alpha and eta are the hyperparameters. Is it clear to all? No one is responding.
Yes, ma'am.
Okay. Please respond. It's my humble request. Now let us see. I was saying that alpha was a hyperparameter. So this question will help us to understand why is it so. So please attempt this question and put your answers in the chat box. Please give it a try, everyone. These are very interesting conceptual questions. If you have gone through lecture 43 now, 42, then this all the things will be very very clear, and it will help us to relate whether we remember the content that was discussed, whether we understood it or not. If not, we can go again back and revisit the concept. So please give it a try. So here, this alpha is a hyper hyperparameter to control topic distribution assignment. I'll give you 2 minutes to solve, then we will discuss. Here also it can be multiple option correct. Option 1, option 3 can be correct, 2, 3, 4 can be correct, 1 or 3 can be correct. So please mark all the correct options. Please put your answers in the chat box. Please attempt. This is 1. Okay. There can be multiple options correct, Vidya. Please try again. And any other answers, please put in the chat box. I shall discuss? Please respond. So, okay, I will tell. Here the correct answer is option 2 and option 3. Like when alpha is greater than 1, it has been explained in the lecture through the statistical analysis as well as the simulation results that when alpha is greater than 1, they have shown like these kind of two graphs in the lecture. Towards the center, it's very dark, and in yet another graph, it tries to be like this way conical. This is for alpha less than 1, and this distribution is for alpha greater than 1. When alpha is greater than 1, it tends to assign equal probabilities to all the topics. Since we know a document can be a blend of multiple topics, or let's say I have multiple words in my document, it can be assigned to the different topics at the same time. That's why this parameter alpha, it tries to see what is the probability that I should give to a particular topic. That's why we try to model probability of the topic ti given the document dj, and this will go over all the topics for all I belongs to k, like k is the total number of topics that you have. So in this case, it will try to see whether a single any time whenever it is alpha is less than 1 and alpha goes greater than 1. Whenever alpha is less than 1 means high probability, it is biased. Like it will tend to prefer certain topics that are having a higher probability than the others. And in case alpha is greater than 1, it tries to assign them equal probabilities. And this we can also discover with the help of the reverse the latent Dirichlet allocation procedure also. That helps us to assign, like we already know what are the different topics the document can belong to. We try to find the probabilities and backtrack whether it is the corresponding with the initial result that we took in the beginning. So whether a single topic, whenever alpha is greater than 1, high probability, alpha is less than 1, high probability, alpha is greater than 1, uniform probabilities. So more uniform mixture of either many topics or one top. More uniform mixture means multiple topics should be there, and here it can be either a single topic with high probability. Whenever it is less than 1, it is biased. Whenever it is greater than 1, it is unbiased. Just remember this basic concept. Clear to all? Please unmute and ask if there is any doubt. Please
Yes,
tell.
ma'am.
Hello? Yes, yes, please tell what is the doubt.
No, it's clear.
Just remember this key, this golden concept is there, no? This point you should remember when you are attempting this question. Alpha is greater than, alpha is less than 1, biased. Alpha is greater than 1, unbiased. Okay, let us go to the next question. We have just 10 minutes left. Please attempt this question. Here all the four options can be correct. Here it can be multiple option correct, or it can be like two only options are correct. So please mark carefully. All the points corresponding to this have been covered in lecture 44. And I'll explain every statement. So I hope you will give it a try and mark all the correct answers. Give it 2-3 minutes to solve. Just statement based questions. Multiple option correct. You have to find the disadvantages of simple LDA model over its variants. I'm giving you a big hint here. Just think of all the variants that you studied in lecture 44, and based on that, you can answer all these questions. This is a very important topic in natural language processing. A lot of research papers and still a lot of work is being done in this direction. Topic modeling. Very, very important topic. Please go through the lectures again if you didn't understand. Please write to me in case you have any doubts based on this topic or any concept. This is my email address. You can mail me, and all the discussions related to today and previous sessions for problem solving I am uploading on this channel, so you can go and visit. Please please pay great attention to this topic. It is very, very important. Please put your answers in the chat box. We will discuss in 2 minutes. Three and four. Okay. Anybody else? Have you attempted? Put your answers in the chat box so that I can know. Only Sandeep has attempted, it seems. There are three people more, right? Please, all other three, please put your answers in the chat box. Do you need more time or shall I discuss? At least let me know that. Guys, am I audible?
Yes, ma'am. 1 and 4. Okay. Okay, I shall discuss. I need some time to solve this question. So let me tell you. I think I already told the answer in the beginning, but no one listened it carefully. Even before solving, I told. All the four options are correct. You know why? Let us see. It says that a number of the topics has to be pre-specified.
This is a very big disadvantage. We are considering, I told you very clearly, we are taking the simple LD into account. And in that, we need to, if you remember this graphical model of LDA that we discussed, if you see here this K, we need to specify these number of the topics. We need to specify. Although there are the variants available in which you need not specify the topics, that is in case of the one of the variants that you cover in the lecture is lecture I think 45, that is the non-parametric Bayesian models, Bayesian LDA models. There you need not need to pre-specify the number of topics. There it can work, but since we are considering the simple LDA model, you need to pre-specify, matlab specify beforehand, before proceeding. And we saw already in the graphical model that is denoted by the variable capital K. Okay, is it clear to all?
Yes.
Okay. And then it says it cannot capture the correlation between the topics. This is 100% correct statement. Why? Because it is just trying to produce the probability, like the probability of the topic given a particular document. But it is not trying to model whether the topic T1, what is the probability of the topic given the topic T1, or the probability of the topic T2 given some topic T small k. It does not try to identify this. So one of the variants of the LDA that is available for this is the correlation topic models. And how does it do that? In the case of, I will explain in detail. In the case of correlation topic models, and in the case of simple LDA, here it uses the Dirichlet distribution to assign probability to the topics. We saw alpha, that is used to control what topic should be given what probability, right? Probability of the topic that is controlled by this hyperparameter alpha. But in this case, correlation topic modeling, it uses what logistic regression, multivariate logistic regression it uses to learn what is the correlation between two different topics. Okay, I hope it is understood now why the statement was a disadvantage. Then bag of words assumption, sentence structure is ignored. LDA ka basic concept is it works on this bag of word structure only. Why? It will just see what is the what is the word W1, what is the word W2 that is occurring in the document. It will not take into account whether W2 occurs before W1 or W1 occurs before W2. This kind of sequential order or the temporal order, like let's say temporal would also be like this only, whether W1 occurs at the time step t or W2 occurs at the time step t, or what word occurs at the time step t plus 1. This kind of information it does not take into account. Bag of words refers that the order of the words will not be preserved. It will not take into account this order. It will completely ignore. It will just see whether the word W1 occurs or not, present or not, W2 present or not, but not this information W1 occurring before W2 or W2 occurring before W1. So if we want to capture this information, sentence structure is ignored. What kind of model we can use in this case? You need to use some variant, but simple LDA definitely cannot capture this distribution. And then it says that the simple LDA cannot model the topic dynamics in the corpus that are spanning over long periods of times. This statement is also a disadvantage of the simple LDA. And for this, the variant of the LDA that is proposed is the dynamic topic models. So here what they try to do is like, this is covered in great detail in lecture 44. I would encourage you to go and see the lecture again in case you do not understand. So in dynamic topic models, it tries to see like what is the like, let's say I got some beta k at the time step t. It will take it as one distribution. Then for the similar topic, and it will also try to get its mu and sigma. Mu is the prior mean, that is the prior information of the topics, and sigma refers to how these topics vary over the time, like what is the correlation among them. This is just a variation over, I think, the correlation topic models, just a slight extension, that here the mu of the time step t from beta k, that would be fed as an input to that would be fed as an initial input to the beta for the topic. Same topic we are trying to again calculate a distribution, but at the time step t plus 1. So that this will be served as an input to it. So for great detail you can go and refer to the lecture, but as of now this is the explanation, and here the answer is 1, 2, 3, 4. All are correct. Is it clear to all? Is it
Yes,
clear?
ma'am. Yes, ma'am.
So Sandeep and Satish both were right, but partially. Option 2 is also correct. Is it clear why the statement is correct and what is the corresponding alternate for that simple LDA? Which variant we will use and why?
Yes, ma'am.
Okay, great then. So I think we are close to 7 p.m. Yeah. So let us meet in the next session. Please pay great attention to this topic. This is very important. In case you have any doubt related to today's problem solving session, I'll upload the channel on this video on this link. And in case you want to have your any doubts to, and in case you still have any doubts, you can write to me at this email address. So thank you all for joining. Hope to see you in the next session as well, next Saturday.
Thank you.
Thank you. Thank you so much.
Thank you, ma'am.